Question 4. The lateral faces of a regular pyramid are composed of. So the question is like this. The lateral faces, that's these four, the outside four faces of a regular pyramid. A regular means that they're all congruent, are composed of. So let's go through the answers. 1. Squares. It can't be true because squares don't make up a pyramid. 2. Rectangles. Rectangles don't either make up a pyramid. 3. Congruent right triangles. It's not right triangles, so it can't be true. So the only possible answer is 4. Congruent isosceles triangles. You have all these are congruent isosceles triangles.
Question 5. Point A is located at 4, -7. 4. The point is reflected over the x-axis. The image is located at, if we reflect this over the x-axis, it's going to be both the y is going to end up switching signs. If it's a positive, it's going to end up into a negative. If it's a negative, it's going to end up into a positive. Only the second one, not the first. So it's going to end up being 4, 7. Right over here. 4, 7. So, therefore, our correct answer is 4, 7, which is number 3. Because it's not negative 4 because we're going to change the first one. So, and we're going to switch around the numbers. So, that's the only possible answer.
Question 6. In the diagram of circle O below, chords AB and CD are parallel, and BD is a diameter of the circle. If measure AD equals 6D, what is the measure of CDB? So, since they told us that AD is 60 degrees, so arc BC is also going to be 60 degrees. Since parallel arcs are congruent, then you know that this is. Question 6. In the diagram of circle O below, chords AB and CD are parallel, and BD is a diameter of the circle. So if measure AD equals 60, question 6. In the diagram of circle O below, chords AB and CD are parallel, and BD is the diameter of the circle. If measure AD equals 60, what is the measure of CDB? So since they told us that measure AD is 60, so then we know that measure BC is 60, because parallel lines, the arc is going to be congruent. So since once we know that this is 60, we're going to know that measure CDB over here is going to be 30, since inscribed angles are half of the arc, so it's 30. So the answer will be number 2.
June 2008 Geometry Official Sampler Test. Question 1. An isosceles trapezoid ABCD, so it's ABCD. That means A is the further away from C than it is D and B, because it's not AC, it's AD or AB. So it's ABCD. It's isosceles trapezoid means that the two sides are equal. This side is equal to this side, and when you have an isosceles trapezoid, one of the rules is that the blue diagonal is equal to the purple diagonal. The two diagonals are equal. Diagonal is the furthest point from one to the other is a diagonal over here. Now, what are the diagonals? It tells us that in this trapezoid ABCD, diagonal AC, you have diagonals AC and BD, which you would have known yourself, because they can't be next to each other. It's not AC, it's AB or AD. But it's AC is one diagonal, the other diagonal is BD, and you know that they're equal. And it doesn't say that they're equal, but you know that. because the diagonals of isosceles trapezoid are equal, and it tells us that AC is equal to 5x plus 13. That means dB is also equal to that. And it tells you that dB is equal to, line dB is equal to 11x minus 5. And then it asks you, find the value of x. Well, let's find the value of x. We know that they're equal, so let's make this equal, right? We'll do AC. AC is 5x plus 13. And dB is equal to dB. And what's dB? dB is 11x minus 5. Let's get all the numbers to one side, all the numbers to one side, all the letters to the other side. So what we're going to do is add 5 to both sides, add 5 to both sides to get rid of the negative 5. And also, because you have more letters on the left side, so getting rid of the numbers. Could have done it the opposite way also. Add 5 to both sides, get rid of the negative 5 on the left side, subtract 5x from both sides, subtract 5x on both sides, get rid of the 5x on the right side, and when you get rid of the 5x on the right side, there's no 5x, because 13 plus 5x minus 5x is 0 5x, and 11 minus 5x is 6x, and 13 plus 5 is 18, so 6x is equal to 18, right? Because you have 5x minus 5x, and 11 minus 5x is 6x. It's a negative 5 on the left side, add 5 to get rid of it, and add 5 to the other side to keep the equation equal. So 13 plus 5 is 18, so 6x is equal to 18. Divide both sides by 6, and you get x times 6 divided by 6 is equal to x. 18 divided by 6 is equal to 3. And the question is, what is the value of x? The answer is 3, which happens to be answer 3. Question 2. What is the negation of the statement the sun is shining? So if you want to say the sun is not shining, so some people say the sun is shining, not, but that's not how you speak. The way you do it is, you put the not where it's supposed to go. You nod it in, the sun is not shining. Right? You don't say the sun is shining not. You negate it, you have a sun that's shining, so you put into a sun that's not shining, and they cancel itself out. Only mathematically, only in geometry. But you see, the sun is shining, the negation of that is the sun is not shining, which is answer 3. Now answer 1, they say that it is cloudy. That doesn't mean the sun is not shining. The sun might be shining somewhere else. Or the sun might be shining somewhere. Or it might be the sun is not shining because it's cloudy, but it's not the opposite of. You're not minusing a sun is shining. To minus a sun is shining, you have to say the sun is not shining. Answer 2, it is daytime. Also, it is daytime. We just said it may be cloudy, right? So the sun might not be shining. And also, answer 3, it is not raining. Could still be cloudy. It could be dark. It could be night. The sun, that doesn't make a difference. The only answer, which is a negation, which is a negative of the sun is shining, is the sun is not shining. Answer 4. Question 3. Triangle ABC has vertices. A is at point 1, 3. That means x is 1, y is 3. B is at point 0, 1. And C is at point 4, 0. Under a certain translation, A1, the image of point A is located at point 4, 4. So what happened to point A when it moved from A to A1? Well, the x moved over 3, right? Because the difference between 1 and 4 is 3. It was at 1, the x, and moved to 4, so it's a difference of 3. So the x has a translation of adding 3, and the y moved from 3 to 4, so the y moved over 1 and moved 1 up, so it has a translation of plus 1. So the translation is from a to a1 is a translation of x plus 3 and y plus 1. Now, under this translation, point C is located where? Well, let's check it out. Point C, to do C, we'll take C, and C is what? C is 4, 0, with a translation of 3, 1. That's what happened to the triangle, right? We had to add 3 to make A1 4, and we had to add 1 to make the y to make the y from 3 to 4. We had to add 3 to make the x from 1 to 4, and we had to add 1 to make the y from 3 to 4. So to do the same thing, you have to do the same thing to everything, because that needs a translation. Everything is under the same translation. So C is x, y, x is at 4, translation of adding 3. So 3 plus 4 is 7. That's C1. And y is 0 plus 1 is 1. So the correct answer is x is 7, y is 1, which is answer 1. Question 4. The diagram below shows the construction of the perpendicular bisector AB. You had line AB, and you used the compass to create a perpendicular bisector, and it came out that the perpendicular bisector is at point C. Which statement is not true? So in other words, it's telling you 3 statements are true. You can learn a lot of math on the regions itself, because a lot of times in all the multiple choice, you're given 4 questions and you know that only one of them is correct. So you know for sure that the other 3 are not correct, and especially when you could figure out the answer, you could cancel out the wrong ones, then each one you could go over for a second to remind you how these things work, especially when you're going to use it for proofs when you write a statement and a reason. Fine, now which one is not true? Is AC equal to CB? Well, perpendicular bisect means it splits it in half. So it splits it in half at point C. So AC is equal to CB. So this is true. CB is equal to half of AB. Well, CB is half of the line, and AB is the whole line. So it's also true. AC is equal to 2 of AB. No, AC is equal to half of AB. So this is false. And always go through all the answers. AC plus CB, that means this half plus this half, is equal to AB the whole. That's also true. So the correct answer, which one is not true, is answer 3. That AC, which is half of it, is not equal to double the amount of the whole thing. Question 5. Which graph could be used to find the solution to the following system of equations? Y equals negative x plus 2, and y equals x squared. Well, negative x means that the slope is going down, because when y is positive, x is negative. When x is positive, y is negative. So, therefore, in this slope, it has to be going down. So answer 1 is out, because over here the slope is going up. Plus, when x is 0, y is supposed to be at 2. This is correct, but the slope is going up. Over here, it's x times a negative 1. It's a negative slope, so answer 1 is not correct. So you erase answer 1. Answer 2, you have a negative parabola. It does not say that y equals negative x squared, so answer 2 is also not correct. Because a negative parabola, when y equals negative x, it opens up downwards. So answer 2 is also not correct. Answer 3 is, well, it starts at 2. When x is 0, y is 2. And it's a negative when x is 1, y goes down 1. When x is 2, y goes down 2, and so on and so forth. When x goes to 3, y goes down to negative 1. So therefore this is correct, and also this is like y equals x squared. That means when x is 1, y is 1. When x is 2, y jumps up to 4, because it's 2 squared. When x is negative 1, y is negative 1 squared. So it still goes up. When x is negative 2, y is negative 2 squared, which is 4, so it goes up. So answer 3 is correct. Answer 3 will solve both of these. Y equals x squared, and y equals a negative slope with a y-intercept of 2. Let's see answer 4. Answer 4 is a line like this. One of the lines, the line is parallel to the x-axis, so there's no negative slope. So even though the parabola is correct, but there's no slope, answer 4 is not correct. So the only correct answer is answer 3. Question 6. Line K is drawn so that it is perpendicular to two distinct planes. Or just read it, line K is perpendicular to planes P and R. What must be true about planes P and R? Well, P and R are both parallel to each other because we have a theorem that if two planes are perpendicular to the same line, then the two planes are parallel. So that's answer 3. Planes P and R are, that's answer 2. Planes P and R are parallel. Let's try out the other answers. Answer 1, planes P and R are skew lines? No, the skew lines are not parallel, but they still don't meet. So that's not the answer. Answer 2 is the right answer. Planes P and R are parallel because these are the two planes. Right, here's a plane over here. Here's another plane. And there's a line that's perpendicular to both of them. So therefore, these two planes are parallel to each other. So that answer 2 is correct. Answer 3, planes P and R are perpendicular. They can't be perpendicular because they are both perpendicular to the same line. So they have to be parallel. Answer 4, planes P and R, plane P intersects plane R. It cannot intersect plane R, so answer 4 is not correct. And it also says plane P intersects plane R, but it's not perpendicular to plane R. So it's true it's not perpendicular to plane R, but it does not intersect R because they are parallel, because if you have two lines that hit another line at 90 degrees, so that means that they're going in the same direction. They have the same slope, for example. So they're parallel. So the only answer, which is the correct answer, is answer 2. And question 7. The diagram below illustrates the construction of PS, line PS, parallel to line RQ through point P. So here's a line, here's line PS, here's line RQ, and it says that they're parallel through this transversal. And it also shows you two angles, and it shows you angle 1 and angle 2. It makes one line from through each one, which means that they are the same angle. That means if this is 30 degrees, this is also 30 degrees. So which statement justifies this construction? Let's try answer 1. Answer 1 is that angle 1 is equal to angle 2. That does justify this construction because there's a theorem that if two lines are cut by a transversal such that the corresponding angles are congruent, then the lines are parallel. Or you could say the opposite way. If a transversal cuts parallel lines, the corresponding angles are congruent. So angles 1 and 2, you see they're equal, so they're congruent. And if you know that they're congruent, and you have two lines, and when the line cuts through it, it makes two angles that are the same, the only way you could do it is if the two angles, if the two lines that this line goes through, is the two lines that goes through must be parallel to each other. Because what would happen if you would have a line that goes like this? right? So then, the angle, or better yet, you have a line that goes like this. It goes like this a little down. So what happens? This line cuts it, but this angle is not equal to this angle because this is a little wider, you could see. So the only way that these two angles could be the same if one line cuts it, the only way to do it is if the lines are parallel. So the only correct answer is answer 1. Answers 3 and 4 cannot be correct because we don't know how long PS and RQ are. So answers 3 and 4 it can't be. Answer 2 it cannot be because this is angle 3 over here. Angle 3 is right here. And as you see, angle 3 is greater than angle 2. Plus, even if it would be the same, but angles 1 is equal to angle 3 would not help us. It would not prove that this theorem. The only theorem we have to prove it from the 4 answers is answer 1, which is angle 1 is equal to angle 2, and if two lines are cut by a transversal such that the corresponding angles, angle 1 and the corresponding angle means the angle in the same position are congruent, are equal in width, equal in angle, then the lines are parallel. So the only correct answer for 7 is answer 1. Question 8. In the figure in the diagram below is a rectangular prism. Which statement must be true? Let's go through these statements. DE is congruent to AB. The length of DE is equal to AB. Well, we can't prove it. We cannot prove it because it does not say that the triangle that makes this prism is equilateral. So therefore, we don't know that. So therefore, it's not answer 1. Let's try answer 2. AD, the line in the back, is equal to BC. Well, there's no way of proving that, at least not from the information we have. Answer 3, AD is parallel to CE. Well, they're all on the same plane. Two lines that that's the same distance. Over here it's the same distance from the top to the bottom. Over here it's the same distance from the top to the bottom, because otherwise it would not be a triangular prism. Triangular prism has equal top and bottom, and therefore also you have lateral edges of a prism, of a rectangular prism. AD is a lateral edge. It's an edge, just like BC is an edge. It's a line at the edge. AB is a line at the edge. And over here, AD is a line at the edge that's the same type of line as CE. So AD and CE are parallel. So that is correct because lateral edges are parallel, because AD and CE are both lateral edges, so they are parallel. You see that they're represented the same way if you look at the diagram. Now DE, line DE is parallel to line BC. Line BC is up here, and DE is over here. DE is going in this direction. It would intercept CE. So therefore it's not parallel. So the only answer that could be is answer 3. Question 9. Question 9. The vertices of triangle ABC are, A is -1, 2, so you go x -1, y 2, and B is -1, I should switch this around, it's a mistake. A is -1, -2, so this is A. B is -1, 2, so this is B. And C is 6, 0. So it's a triangle, so let's put together this triangle. Here's a triangle. Connect these two dots. You have the one side of the triangle, second side of the triangle, a third side of the triangle. Let's figure out what we know about this triangle. Well, we know that B and A are on the same line where x is equal to -1, right? This is their line, x is equal to -1. And C is at 6. So and they also, B and A are both 2 away from the x-axis. So therefore, you can make a bisector, an angle bisector, for angle C. And what that means is, and it goes across the x-axis, and that's both 2 away from A, because A is -2 down, and B is +2 up. So what do we know? We know that this is an isosceles triangle. You have 2 sides that are equal. What's the rule by isosceles triangle? Well, the 2 angles that are